Hey everybody, today we will be talking about interval and inequality notation. Interval and inequality notation is used to describe a set of numbers, but specifically in the future you will use it to describe the domain of a graph, the domain being all of the x values the graph exists on. Let's start off this lesson with the number line. And on this number line, our x values would be 0, 1, 2, and 3, and -1, -2, and -3. And we're going to draw a line starting from 0, going to 3. Now to figure out the interval and inequality notation of this line, we're going to note some information. Well, let's see. First of all, we can tell that all of the x values in between 0 and 3, like 1 and 2, are included as part of this line. Okay, that's one thing to note. Another thing to note is that 0 and 3 themselves are also included as x values. Why is this? This is because there are closed circles above the values of 0 and 3. 0 and 3 are the endpoints. 0 is the left endpoint of this line, and 3 is the right endpoint of this line. So we know that this line starts from 0 and goes to 3, and we know that 0 and 3 themselves are included as well because of these closed circles. Using this information, we can write our interval and inequality notation. Let's start off with our interval notation. Well, like we said, this line goes from 0 to 3, and all numbers in between of those two values are included. So we'd start off with 0, 3. And since we know 0 and 3 themselves are included because of these closed circles, we would put brackets around them to indicate that. And this would be our interval notation. Now, what would our inequality notation be? Well, our inequality notation basically states the same thing as the interval notation, but is written differently. And in this case, it would be 0 is less than or equal to x, which is less than or equal to 3. If you look at this closer, we'd see that we know all values in between 0 and 3 are included as x because of this less than sign, and we know that 0 and 3 themselves are also included as values because of this equal sign. So our inequality notation for this example would be 0 is less than or equal to x, which is less than or equal to 3. Okay, let's move on to another example. In this example, we're going to have another number line. And we're going to have the same exact values with 0, 1, 2, and 3. And then -1, -2, and -3. But this time, our line is going to look like this, with an open circle on 0, going to 3, and an open circle on 3. Now let's remember what I talked about in the last example. I said that 0 and 3 are included values of this line because there are closed circles above them. Well, in this case, we have open circles. So it's pretty easy to understand that since closed circles means that these are included values, open circles would basically state that these are not included values. Okay, well, let's use these new open circles and the information we already gained from this example to figure out what the interval notation would be. Well, we still know the values in between 0 and 3 are included as values because this line goes from 0 to 3. But now we know that 0 and 3 are not included because of the open circles. Well, first, let's start off with 0, 3 because the values in between those two values are still x values of the line. But 0 and 3 are not. So instead of using brackets, we'd use parentheses to indicate they are not x values. And this is our interval notation. What would our inequality notation be? Well, it would just be 0 is less than x, which is less than 3. We wouldn't use an equal sign in this case like we did in this example because there are open circles which indicate the fact that 0 and 3 themselves are not x values of this line. This is our inequality notation. Now that we've understood the topic of closed circles and open circles with interval and inequality notation, let's move on to another concept, infinity. And on this number line, we're going to have 0 in the middle, positive infinity on the right, and negative infinity on the left. And our line will simply be continuous line going in both directions. Well, let's take a look at this. Okay, so let's take a look at negative infinity and positive infinity. Infinity is continuous. It keeps going on and on and on. It is not a defined value. So since it's not reachable, since it keeps going on and on and on, this line will keep going towards infinity but will never reach it. It keeps reaching infinity. Same with negative infinity. This line will keep going left towards negative infinity but will never reach it because negative infinity is continuous and not a defined value. But by looking at this continuous line, we can state that all values in between negative infinity and positive infinity are included as x values of this line. Using this information, we can write an interval in inequality notation. Let's start off with the interval notation. Well, reading the line from left to right, we can see all values in between negative infinity and positive infinity are included. So we can start off with negative infinity, comma, positive infinity. And since negative infinity and positive infinity are not included because they're continuous, and can't be reached, we would just put parentheses around them. In interval notation, whenever you write negative infinity or positive infinity, there will always be parentheses next to them. And that's our interval notation. What would our inequality notation be? Well, it would just be negative infinity is less than x, which is less than positive infinity. And this is pretty easy to understand. Just like in this case where there was open circles for 0 and 3, we figured out that 0 and 3 are not included values. Well, there's no open circles on negative infinity and positive infinity, but like I said, these are continuous unreachable values and therefore can't be included as part of the x values and therefore can't equal x. So this would be our inequality notation. Okay. Let's do one more number line example with the concept of infinity. We're going to have 0 here, but this time we'll just have 1, 2, and 3, and negative infinity on this side. And our line will simply just be this. So if we look at this line, we can say that it's continuous towards the left side, but not on the right side. And then it stops at the x value of 3. Okay, good. But notice that there's a closed circle above 3, so that indicates that 3 is an included value of this line. Okay, using that information, we can figure out the interval and inequality notation. Okay, reading this line from left to right, it goes from negative infinity towards 3. So we have negative infinity, comma 3. Is negative infinity included? No, so we put a parentheses. And is 3? Yes, because of the closed circle. So our interval notation for this example would simply be negative infinity, comma 3. Well, what's our inequality notation? Well, judging from the interval notation, we can just figure out that our inequality notation for this case would just be negative infinity is less than x, which is less than or equal to 3. Since 3 has a closed circle on top of it, it is an included value, and this line just continuously goes to the left towards negative infinity. Therefore, this would be our interval notation, and this is our inequality notation. Okay, now let's move on to some graphical examples. In this case, we have a line, not straight like our number line examples, but diagonal. But if you look closely, you can see that in this line, it's going continuously towards the right, and it's also going continuously towards the left. It has arrows on both sides, just like we did in this number line example. You don't have to judge if the line is going horizontally straight, but you can see that it's going to the right and to the left on both sides. So that's why our interval notation for this example would simply be negative infinity, comma positive infinity. And our inequality notation would just be negative infinity, comma negative infinity is less than x, which is less than positive infinity. Just like in the number line example we did. Notice how there's 2 arrows on both sides of the line, and when it is like that, then you know that the interval notation would be negative infinity and positive infinity. And the inequality notation would be negative infinity is less than x, which is less than positive infinity. It is important to note too that there are only closed circles in between these lines. There's a closed circle on 5 and there's a closed circle on 0. So we know that 5 and 0 are also included as x values. Okay, let's move on to this. Now this is a different shape called a parabola. Well, if we look closely, we see an arrow on this side going towards the right, and we see an arrow on this side going towards the left. Well, if you think about it, it's basically the same as this. It has two arrows on both ends of the line, one going to the right and one going to the left. So our interval and inequality notation would be the exact same as this, with negative infinity, comma positive infinity being our interval notation, and negative infinity is less than x, which is less than positive infinity, being our inequality notation. Okay, there we go. Now let's move on to some examples that don't include infinity. Well, here we go. It's just a simple straight diagonal line with a slope of 1. How would we write our inequality and interval notation for this? Well, let's look at it closer. If we count, we'll see negative 1, negative 2, negative 3, and negative 4. Negative 4 is the x value at which there is an endpoint of the sign. If we count to the right, we see 1, 2, 3, 4. 4 is the x value of the endpoint of this. So if we look closely, our interval notation would start off with negative 4, comma 4. Now we have to look at the circles. Are these closed circles? Yes. Since these are closed circles, we would put brackets around them, and this would be our interval notation. Now, from looking at the interval notation, you can figure out that your inequality notation is just negative 4 is less than or equal to x, which is less than or equal to 4. Okay, on to the next example. If we look at this, it looks a little bit different, but once again, we just have to look at the domain. If we count to the left, we have negative 1, negative 2. Boom, this is the x value for the endpoint of the left side of this line. So we know that it starts on negative 2 and goes to the right. But where does it go to? All the way to the right, which means it's reaching infinity. Okay, so we know that the x values included are between negative 2 and infinity. Is negative 2 included? Yes, because there's a closed circle, so we put a bracket. And since this is a positive infinity, we'd put a parentheses around that, and this would be our interval notation. And our inequality notation for this case would just be negative 2 is less than or equal to x, which is less than positive infinity. Okay, on to another example. Now this is just the shape of an M, but once again, we're just trying to find the domain. If we count to the left, we see negative 1, negative 2. Okay, negative 2 is the endpoint for these conjoined lines. If we count to the right, we see 1, 2. Okay, so we see 2 over here. So negative 2 is the left endpoint, and positive 2 is the right endpoint. So our interval notation for this would simply just be bracket negative 2, comma 2. And our inequality notation would just be negative 2 is less than or equal to x, which is less than or equal to 2. Okay, this last one, try on your own. Pause the video and see if you can figure it out. Okay, for this case, the interval notation would just be parentheses, negative 3, comma, 5, parentheses. And our inequality notation would be negative 3 is less than x, which is less than 5. And we can see this by the open circles of the endpoints. Since these are open circles, we would put parentheses around it, and we would just make them less than. So these are interval and inequality notations. So this was the lesson on interval and inequality notation. If you enjoyed this